Now, when it comes to defending your networks from fast-moving attackers, you folks will no doubt be feeling a heightened sense of pressure. Threat actors are speedier than ever at churning through IP addresses and camouflaging themselves within organizations' cloud infrastructure. So, to share some much-needed insight, I'm delighted to say that for our next session, Secureworks are teaming up with Amazon Web Services to share both of their perspectives on the most effective strategies in the face of these evolving challenges. Secureworks senior security researcher Keith Jarvis is joining us again, along with Charles Roberts, who's a senior security consultant at AWS. Great to have you both with us for this. Thank you for being here. With that, I'll give you the floor.
Thank you.
Thank you so much. Well, again, my name is Keith Jarvis. I am a senior security researcher with the Secureworks CTU. I focus on malware research, threat intelligence, tracking the different threat groups that are financially motivated, and that ends up being mostly ransomware groups.
And I'm Charles Roberts. I'm a senior security consultant. I help our customers run their most sensitive workloads in the cloud.
So today we're talking about defending against dynamic attacker networks. So we want to talk about the dynamic environment that attackers are trying to maintain and create at all times. So in general, attackers want to always be presenting a moving target until the final stages of their attacks. So with the exception of DDoS attacks or dropping the ransom note on a machine after they've completed their attack, attackers want to go undetected. And one of the main ways that they can go undetected is to use network infrastructure that's either fast-moving or hard to detect. So defenders have two challenges to successfully execute traditional network indicator-based defense with shortened time frames. So that means the indicators today last for much less time than they did 2 years ago, 5 years ago, etc. And the second challenge is to detect abuse within your own cloud platform that's being used for malicious infrastructure. So from Secureworks' perspective, we see these as the three major ways that threat actors get into networks that we protect. In the center is commodity malware at 8%. These are year-to-date 2024 figures, so it's a low number. This is a number that has been steadily declining over the last several years, and we'll get into some of the reasons for that during this presentation. But together, these three are the majority of ways that the threat actors get in. So we've got credential theft and use. They come through remote access platforms like RDP and Citrix. In some cases, these are attacks that are malware enabled through info stealers that will actually steal the credentials. They'll go to a marketplace, they'll be purchased, and then they'll be used by a threat actor to get in. And the same for scan and exploit. So if you're on the public internet, if you have a service on the public internet and it's vulnerable to an exploit, it will be exploited. The threat actors will get onto that machine, and they may use malware at some point during that intrusion, though not necessarily. So the malware landscape really has been changing over the last 5 years. We've come up with this terminology at Secureworks where we split the botnets, the malware threat, into two general buckets. One is the monolithic botnet. This is a long-running botnet that intends to capture large pools of infected systems to keep them in the botnet for weeks, months, even years at a time before they're actually used for some sort of intrusion purpose. These botnets typically have infrastructure that is long-lasting, and there are facilities within the botnet to push out new updates to infected systems. So new sets of C2 servers or commands to run, etc. The second type of threat we're seeing increasingly over the last several years are the so-called ephemeral botnets. And these are intended to be very short campaigns that may last hours to days, sometimes weeks, but the intent is to carry out one task, usually to steal credentials or to load an additional malware family, and then the infrastructure that's used for both of those things quickly goes away. So that is what's putting most of the pressure, that's lowering the time that network indicators are viable and usable for blocking. So some effective protections for using network indicators, domain IPs for block lists. The methodology that Secureworks uses is not to discover an indicator and then publish it with some sort of arbitrary TTL. So saying we found a C2 server, we're going to put it in a list for 6 months. We found that really isn't effective for defending networks because Like we'll talk about, these indicators do have an expiration date. So after we discover something, we continually assess whether or not that command and control server is speaking the particular protocol, and that way we can continuously update our block list to make sure it has high fidelity indicators remaining in it. That being said, when something stops being malicious, we do give it a TTL of about 48 hours to allow systems to sort of age it off naturally. And that's kind of an arbitrary figure. We tinker with that every once in a while based on the metrics that we get back from our systems. But we've kind of settled on a 48-hour TTL at this point. And of course, none of this really makes a difference if you're not regularly applying these block lists to security controls available to you, such as in the Taegis platform or in Amazon GuardDuty.
The first service I want to talk about in terms of detecting is Amazon GuardDuty. Amazon GuardDuty is a machine learning powered threat detection service. It takes feeds from a number of different sources within the AWS platform. For example, AWS CloudTrail, which is looking at user activity and service activity, flow logs, which is looking at the network traffic across the platform, and DNS traffic as well. It uses machine learning to do anomaly detection, but it also will use third-party threat intelligence sources as well. It's very, very simple to turn on, and I see a lot of our customers using GuardDuty to automate the threat intelligence that they're going to get from the AWS platform. The next thing it will do is it will also integrate with a number of other services. So for example, AWS Security Hub automatically collates all of your findings and gives you a centralized visibility so that you can see security across your AWS environment. From there, we can also store security findings in AWS Security Lake. It's backed by S3 storage, so it's relatively cheap to store a vast amount of findings, and it's also been normalized using the OSCP format. From using Security Lake, we can then integrate with a number of platforms so that we can perform analysis. So we're using platforms like Amazon Athena, which can then have visualizations using QuickSight, and also OpenSearch as well is another common pattern I see. But we also have integrations with lots and lots of third-party services such as Taegis.
Right. So having VPC flow logging enabled is a great choice if you have AWS. Even if you're not taking action on the data, which is unideal, you still do have a forensic log of everything that's coming into and out of your network should an incident happen. But we know if we collect security telemetry, the best thing to do with it is to take action on anything that we find in it. So you can use GuardDuty to do that, and the different platforms that Charles mentioned, such as Taegis. There is a direct integration with AWS VPC flow logs and Taegis. Here's the documentation on how to integrate that. And what happens is these raw flow logs come into S3, they're pulled by Taegis into the platform. They're normalized into Taegis entities, and then they're acted upon just as if they had come from any other network telemetry source. And what we found is that really only a small number of Secureworks clients take advantage of this to first enable VPC flow logs and then to actually ingest them into the platform. And we found that they're using it with quite a bit of effectiveness is to detect outbound interactive file transfer sessions or interactive shell sessions like with SSH. They're using it for port scan notification, or they're using it to implement custom alerts with the so-called bring your own threat intelligence that's available on the Taegis platform. So if an IP address that's not in our feed or a third-party feed, but they know is malicious, they can put it into this system, and then if it's seen in those VPC flow logs, they'll receive an alert in the platform. So moving on to by the numbers, so this is where I want to talk about some of the statistical aspects of a threat indicator. What makes a threat indicator? How long do they last? So these are box plots of the big 5 botnets that network defenders have really been up against the wall with for the last 10 years. Each one of these has disappeared over the last 3 years, so this is historical data. But we can see that for some threats like Emotet and Quackbot, and Dridex to some extent, that these network indicators, and you can see on the y-axis that's 600 days. So these indicators can last for years and years and still be valid, though obviously each one has a set of indicators near the bottom that maybe only last days, weeks, sometimes hours. And in particular, Iced ID has always done things a little bit different than the other botnets, moving infrastructure very quickly through their systems, churning it very rapidly, whereas the others have different approaches to that. And in fact, with TrickBot, you can see the different striations there in the indicators, and they were rotating things, every 15 days, every 30 days. So on a schedule, they were rotating things. Now, we might expect this to differ, the distribution to differ with different types of malware families. So loaders and rats, another class that we see pretty frequently in attacks. On the corners here, Warzone and Nanocore, we can see that the indicators are generally short-lived there. The shaded areas in blue are the 50% range. So if you see an indicator in there, that's about 50% of them. Smoke loader is a loader. We would expect it to have short durations for C2 infrastructure, but because it's such an old threat, over 15 years old at this point, they do things a little bit different. They do it in the old school way where they set up infrastructure and they let it last as long as possible. And then thirdly, and this is really where we see the downward pressure on lifetime of indicators, is from the so-called info stealers. These are malware families that get on a system, they run for a few seconds, steal all the credentials, and then they're done. They don't do anything else. They don't persist. They don't participate in a botnet. So it's a very short-lived thing, and we see that reflected in the network indicators. So all of these have median lifetimes of just days, 1, 2, 3 days for all of the families, with the exception of Redline, which is by far the most popular info stealer right now. You can see there are some C2 infrastructure that lasts in the month range, but for the most part, very short duration. So that comes back to the constant evaluation of indicators if they're live and setting the correct TTL on them. So when you collect all of this data and you analyze it, year to date, 2024, so any indicator that we have observed beginning in 2024, we computed the median lifetime of that indicator, and it's just under 2 weeks at this point. And we can see in the graph below that as recently as 2020, it was over 2 months that an indicator would be active. And so if you had a list that you had applied to a security control, you didn't update that very frequently, you got a better chance back then to really to have more chances for detection. But as the years have gone on, as threat actors have changed, we can see these numbers slowly declining down towards the 2-week mark in the last several years. So some observations from us about some real-world cloud abuse cases. So legitimate security testing professionals, red teamers, are overwhelmingly the people that we see use cloud resources when they're attacking networks. It's almost like if I'm doing an investigation in our platform and I see a cloud asset being used, or if I see 2 cloud assets being used, my first thought is this organization undergoing a pen test or a red team exercise? But we do on occasion see threat actors use cloud resources for their C2 channels. Ransomware operators, you might think that services like S3 or any of the other storage options in AWS or the other cloud services would be ideal for bulk data exfiltration, but they tend to use other services like mega consumer-oriented file sharing sites. Malware operators typically eschew cloud services. So when we're talking about the malware families in the previous slides, very few of those indicators in there were based in cloud infrastructure. They typically stay away from the cloud infrastructure, the cloud providers, with the exception of offensive security tooling. So these are the Cobalt Strike and Mythic frameworks that we see in many intrusions. And I think that comes from the fact that those frameworks originate from the red teaming community who do build things to be cloud native, cloud first. So threat actors follow their lead and will often host those types of tools in the cloud very frequently. And then finally, sometimes we see classic APT threat actors who settle on a cloud service. For example, Cloudflare Workers and Bronze Atlas. They figure out a system that works for them, a particular service. Maybe it could be AWS Lambda or something like that that works for them, and they'll stick with it. And we see that pretty frequently as well. So next to move on, another security control that AWS provides is CloudTrail.
So one of the things we want to do is we want to monitor the activity that's going on inside the cloud. And in particular, any suspicious behavior from user activity. So what AWS CloudTrail does is it is keeping a continuous immutable log of activity by users. Now those users could be interacting either as a human user via the console or via the API, or indeed a scripted approach using a modern language such as Python or any of the other languages out there. But CloudTrail is keeping a continuous record of the activity that those users are taking. And so we can use CloudTrail and we can perform analytics, and it is hooked into Amazon GuardDuty, which I just covered. And with that, we can also store that data for a long-term record. So we can put that into services like Amazon S3, and we can then perform analytics on that. And I've talked about some of the analytic tools that we can do that with. And also, it can be integrated into, again, third-party solutions such as Taegis. Another way that we can also look at activity is using a service called Amazon CloudWatch. This gives us observability information. I'm showing just a couple of compute type services here, but CloudWatch actually covers a really wide range of all of the services typically that you would use inside AWS. And if CloudTrail is looking at user activity, CloudWatch is looking at metrics and telemetry coming off all of those platforms. And so what we can do is we can use that to detect activity that we think is unusual. So for example, we have an EC2 instance which would typically have a baseline of running at a certain level of CPU. If we start to see that spiking, or we start to see a high amount of memory consumption or disk usage, it could be a problem with the service for sure, but it could also be an indicator of some kind of compromise. And so we can hook that into our analytics platforms, and we can start to use those metrics to determine whether there is some kind of malicious activity going on.
Right, thank you so much, gents, for sharing that presentation and that session with us. Just to pick your brain on one last piece here, you've shown that having processes to react quickly, first and foremost, to changing attacker infrastructure is really important for defending against that daily onslaught of attackers. But could you walk us through any other advantages, if there are some? Right,
so two key advantages, I think, are in one case, maybe you block a domain that you didn't mean to, like google.com. Whoops, right? Because that's going to cause a lot of pain for your clients. So if you have processes that can work quickly, you can remove that bad indicator from your list. The second thing is we frequently go into an incident response engagement where we want to evict a threat actor. And once we start that eviction process, the threat actor wants to stay in there. So they'll quickly move their own network infrastructure to try and stay in the network. And if you have those processes in place, then you can put in that new infrastructure and keep them blocked.
Right. All right. Well, gents, really, really grateful for you taking the time to be with us today. Thank you so much again.
Thank you.
All right, big thanks, like I say there, to Keith and Charles for their joint insights representing both Secureworks and AWS. And that brings me up to the penultimate session of our core summit event, Context Matters, defending your business with threat intelligence. It'll establish how you can maintain a defensible position with everything that has been shared today, and more importantly, how you can communicate that with different stakeholders in your business. That's up next.